2.6 special functions. So basically we made this simpler this year so that you can understand these piecewise functions. All three of these up here are called continuous graphs because you can draw these without taking your pencil off your paper. Like y is equal to x plus 2 is a diagonal line. Y is equal to the absolute value of x is a v, and y is equal to x squared is a parabola. In fact, you're going to be doing these three shapes in 2.7 next section. So, okay, what's a piecewise function? A function that is written using two or more expressions. So basically here is what a piecewise graph looks like, and we're going to learn how to make these. See, I have to draw one graph, and then I have to pick up my pencil and go over to the other graph, and these are called piecewise graphs. You use these in college algebra and AP Calc. That's all you study are these types of graphs, so you have to know how to make these types of graphs. So here we go. Okay, so you have to watch very carefully on how to make these. You can have, this is called a piecewise graph because it's going to be made up of one different graph, two different graphs. The older you get, you could have 5 different types of graphs on one graph. We're only going to go up to 3, I think, in Algebra 2. So how do you graph both of these on the same graph? You're going to make an XY chart, and you're going to break it, have a piece of it right there, and I only want 3 points for each one. Okay, so I'm going to go nice and slow here. You need to start at 0 for this one, so I need to put 0 at the breaking point, and I need to be less than 0, and I need to put a -1 and a -2 so that these 3 numbers are going from the smallest number to the biggest number. And then if you look at the second graph, I need 3 points down below that other line, and that one has to start at 0, and I need 3 points bigger or equal to 0, which are 1 and 2. Again, you might not catch on to this right away, but after I do a couple of these, you'll catch on. Okay, this one right here belongs to this one right there. These 3 points belong to this one right there. So when you plug a -2 in, which equation do you plug a -2 in? You need to plug it into this equation right here. A -2 plus 2 is 0. You also need to plug a -1 up into that equation, which is 1, and you also have to plug a 0 up there, which is 2. Okay, the next one is you need to plug, in place of all the x's, you need to plug it into this equation now. When you plug 0 in for there, you get 0, 1, and 2, because whatever the number is, the y value is also to that. I didn't talk about what f of x stood for because I already talked about it. That stands for y equals. Well, y needs to equal x in the second one, and they do. The y's do equal the x's. Okay, now comes this other part. Remember when you did the number line on 1.4, 1.5, 1.6, and 1.7, and you had inequalities? When you didn't have a line, you had an open circle. And when you had a line underneath them, you had closed circles. So I want you to put a key. So at this 0, which is this one right here, you see that there is no line underneath it. So this one needs to be an open circle. This one over here, this 0 needs to be a closed circle. And the reason is because of these inequalities. The rest of those 4 points are always closed. Again, you might not understand this until I do a couple more of them. Okay, now we're going to graph it. So the first 3, at 0, 2, I need an open circle. I just did this one. I just did 0, 2, and there's an open circle. At a negative 1, 1, it's a closed circle, and at a negative 2, 0, it's a closed circle. So I just did this one, and this one. And now it needs to be everything less than 0, and that's why the arrow goes in that direction. Okay, now I'm going to do 0, 0, and it needs to be a closed circle. 1, 1 needs to be a closed circle, and 2, 2 needs to be a closed circle. So I just did these three, and it needs to be greater than or equal to 0, where these are all the positive values, and that's called a piecewise function. You might not understand how to do it the first time, so that's why we're going to keep doing a couple more of these. But this is all we're doing today. Okay, let's do 3 more. Graph the equation. I'm going to make a grid, and I know I need a little slash in between because I have 2 different functions. I'm going to start with this one. X needs to be less than 3, so I know right here at the breaking point that that number right there needs to be 3, and this number on the other side needs to be a 3. I need to have 3 numbers, and it needs to go in numerical order, so that's why it needs to be a 1, a 2, and a 3. And this needs to be a 3, a 4, and a 5, because I have to go in numerical order, starting from the smallest number to the bigger number. This section right here belongs to this circled one, everything less than 3. All those X numbers are less than 3, so I'm going to plug a negative 1 up in there, and I get a negative 2. I put a negative 2, I get a negative 3. I put a negative 3, I get a negative 4. So I'm done with those. Okay, now I need to use this, and this is going to go down here. Y, remember this stands for Y. Y is only equaling a negative 1. Do you see that? I can't plug an X value in. Y can only equal a negative 1. It can't be anything else because I can't plug an X value in when there is no X value. Okay, let's see what happens here. At the 3, right here, has to be a closed circle because if there's a less than equal to. And this 3 needs to be an open circle. The rest of them are always closed. It's only at the breaking point that you have to check if which one's the open and which one's the close. So I'm going to use this. 1, negative 2, it's a closed circle. 2, negative 3 is a closed circle. And 3, negative 4 is a closed circle. And it's everything less than that is in that direction. 3, negative 1 is an open circle. 4, negative 1 is a closed circle. And 5, negative 1 is a closed circle. And it looks like that because it's all, I could keep going and do 6, negative 1. Where here's 6, negative 1, 7, 8. We don't go in that direction because it's all the numbers greater than 3. Okay, let's do another one. We have a couple more. Let's do this one. Let's not start at a negative 1. Let's start this one at a positive 2. It doesn't have to start with the same number. So I want to change this one up and show you that the other one does not have to start with a negative 1. I'm going to break this up, and I know right here, these are really important because I know that at the first slash needs to have a negative 1, and the second one needs to start at 2. So that's why those numbers are important. Numbers greater than 2 are 2, 3, and 4. Numbers less than a negative 1 are a negative 2 and a negative 3. Make sure these 6 numbers go in numerical increasing order. Okay, I need to plug a negative 3 up into this equation, and that's how I get a negative 5. Negative 2, negative 4, negative 1, negative 3. These numbers get to be plugged up into this equation. 2 plus 3 is 5. 3 plus 3 is 6. 4 plus 3 is 7. Okay, specifically at the negative 1 marker, it needs to be a closed circle because there's a line underneath it, and at 2 it needs to be an open circle. So those are specific open and closed circles. The rest of them have to be closed. It's just the way piecewise functions work. Now we're going to plot our points, and we're going to use these key to help us. At a negative 3, negative 5, negative 3, negative 5, 1, 2, 3, 4, 5, right here, closed circles. These aren't supposed to be there. At negative 2, negative 4, negative 2, negative 4, and negative 1, negative 3. Those are all closed circles, and it needs to be less than, well, here's x equals a negative 1, and you need to be less than that, so it's all of these in this direction. 2, 5 is an open circle, 3, 6 is a closed circle, and 4, 7 is a closed circle, and it's all of those in that direction. Okay, last one. Just to show you that in higher level math classes you have more than just one. We have 1, 2, 3, and like I said, in college algebra and AP calculus, you could have up to 5. It doesn't matter, you do the same concept. You make an XY chart, but instead of 2, you need 1 section, 2 sections, and 3 sections, because we have 1, 2, 3 different ones. Okay, this is very important to start the first one. You need to start a 2 right there. You need to think of numbers less than 2 so that they go in numerical order. This one starts at 2 on this line, but it has to end at 5 on this line. And I have to come up with a number in between 2 and 5, and I'm just going to use 3. You can use 4, you can use whichever whole number you want. I only want 3 numbers. This one starts at 5, and I have to go 6, and I go 7. Okay, watch carefully. I'm going to erase this so I can see this better. At the 2, it's an open circle. But at this 2, it's a closed circle. At that 5, it's a closed circle, and at this 5, it's an open circle. So those are very important, open and closed circles. The rest of them are always closed. Okay, let's check these off. Oop, we have to fill these in first. This one goes to this one. So in place of 0, you get a 1. 1 plus 1 is 2, 2 plus 1 is 3. This middle one goes to the middle one. All the y values have to equal 3. You can't plug in any x values to find the y. And then the last one is the last one. 5 take away 2 is 3. 6 take away 2 is 4. And 7 take away 2 is 5. So I think you're getting the idea on how to fill the y values in. Okay, now let's graph these. 0, 1 is a closed circle. 1, 2 is also a closed circle. And 2, 3 is an open circle. It's everything less than 3. Well, here's x equals 3. It's everything less than 3, so I know I need to shade in this direction. Okay, the middle one is, all 3 are closed circles. Do you see that? All 3 of these are closed. So 2, 3, 2, 3. So the open circle ends up being a closed circle. 3, 3, and 5, 3. And you connect the dots. And that's it. There is no arrow. There's only an arrow on either side. And then 5, 3. 1, 2, 3, 4, 5, 3. 1, 2, 3, 4. Oh, this was supposed to be 5, 3. Sorry. That's 5, 3. At the other 5, 3, it's an open circle, but an open and a closed circle makes a closed circle. And then 6, 4, and then 7, 5, and then it would have been 8, 6, and it just goes off in this direction. Notice that the first equation and the third equation have arrows on it, but the middle equation can't have an arrow because it's bounded. It's bounded from a 2 to a 5 only. So, okay, those are all the notes for piecewise functions.